Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. So in this video we are going to discuss past year question, which is question number 1D for PSPM 2019-2020, and this question relate to the concept of limiting reactant. So let's read the question together. Magnesium hydroxide is an antacid that is used to relieve indigestion, sour stomach and heartburn. It can be prepared by reacting magnesium chloride and sodium hydroxide with the byproduct sodium chloride. In an experiment, a student allowed 50.1 gram magnesium chloride to react with the mass of the sodium hydroxide it's not this one, sorry, it's only 9.35 gram. Calculate the mass of magnesium hydroxide that could be obtained at the end of the reaction. So because it's involved a chemical reaction, so to solve the problem, you need to write a balanced chemical equation first. So we know that the reaction is between magnesium chloride with sodium hydroxide produce magnesium hydroxide and sodium chloride. Okay, so to balance the equation, we need 2 mole of chlorine, so we put 2 here and we have 2 here. Okay, so now our equation is balanced. So the second part is we have to put the information below the equation. So magnesium chloride that we have is 15.1 gram and this one 9.35 gram. Okay, so as I mentioned previously, if we have the information for both reactant, we need to determine the limiting reactant even though it is not mentioned in the question. So in this case, because we have both, we need to calculate the number of mole because we only can compare mole. 15.1 gram over 95.3 gram per mole, it is 0.158 mole, and this is 9.35 gram over 40, .2338 mole. Okay, so these two number of mole is considered as mole available. Okay, next we need to write a statement according to a balanced equation. 1 mole magnesium chloride equivalent to 2 mole sodium hydroxide. If we have 0.158 mole magnesium chloride, meaning that we have 2 times 0.158 mole, which is 0.316 mole. So this is considered as mole needed. If we compare, the number of mole sodium hydroxide available is less than mole needed. So we can write a statement: mole sodium hydroxide available is less than mole sodium hydroxide needed. Therefore, sodium hydroxide is a limiting reactant. So why we need to determine the limiting reactant? Because we have the information for both reactant. Alright, even though it is not mentioned in the question, but you need to determine the limiting reactant. Once you determine the limiting reactant, now we want to identify how many mole of product formed by comparing with the limiting reactant. Okay, so our next statement is 2 mole sodium hydroxide is equivalent to 1 mole magnesium oxide. Okay, so we need to use the number of mole sodium hydroxide available, which is 0.2338 mole. So 1/2 times, so it will become, so now we want to determine the mass of magnesium is equal to and we will get the answer 6.815 gram. So this is the mass of the magnesium hydroxide obtained at the end of the reaction.